Hey everyone, welcome to my channel. You're watching Advanced Python class with yours only Sandip Das, and I'll be starting the class very shortly. I know, it takes at least 2-3 minutes so that everyone get notified and get aware that the session is getting started. So we'll wait patiently for that. And while I'm talking here, why not you guys just come forward and let me know from which location you're joining, what are the which position you hold, and maybe what are the interesting topics, or maybe what are the things that you want to learn more, or maybe from this session what you want to learn. So, like, let me know. Like, I want to see that all the happy faces commenting how the day going good and all that. So yeah, go ahead and let me know from where you are and all that. Till then, let others. Hey Angelica, I know you are. So just feel free to comment, okay? And till everyone join, just I'll just make the slides ready. Brendan. Hey Guru, good, good morning there. Hey Aditya, great to see that everyone joining. Okay, and I see that everyone joining. Glad to know that. Thank you, Aditya. Yes, Guru is logging from London. Yes, from Kerala. Looks like everyone joining. So I can start the session, and anyone joining late, don't worry. I mean, this session ultimately getting recorded in LinkedIn, not just LinkedIn, getting recorded in YouTube as well, so that anyone joining late, they can go anytime to the YouTube channel and like rewatch again, and you can see while practicing. It's not easy or not always possible to remember every single thing. So it's okay to forget something, then you come back to the video and just rewatch the video, then it will get refresh the memory. Okay, so no worries. We're just getting started. Okay, so very first thing is that so yes, Aditya had one question. Is this full series? Yes, this is a full series. Like, I already started the basics. If you can go to my channel for the basics. For this one is the advanced class. Then there will be functional programming in Python, advanced debugging, like functional that programming. After that, there will be API programming using the REST APIs programming, using Python, the Flask and Django that I want to cover. Then there will be another class on performance optimization and debugging. Then there will be one class in Boto 3. So classes will go on, like each week it will go on and on. Okay, so that's what I'm at this what I'm planning. Let's see. One question is that please continue in Hindi too. Again, Hindi is not my strongest point. I'm a kind of Bengali person background. I do like to make content for everyone, but yeah, I will definitely try. Maybe I will collaborate with other people, maybe Shubham with other people to make some Hindi content as well. So let's see what happens later on. Okay, so looks like everyone joined, and I'll just introduce you the topics of today. First, we'll cover the variable scope. Then we'll cover the advanced function topics, classes, packages, file handling, directories handling using JSON, like how you can use JSON. Because see, ultimately as a developer, I think you'll be mostly working with JSON data. Okay, like fetching JSON data, storing JSON data. Uh, for the database part, of course, it will depend on what database you use. So yes, I forgot to mention, we'll have a special class on how to handle programming with databases. I will cover at least 3 databases, 3 or maybe 4 in a single video. I'll try to make it as short as possible. It will be with MySQL, PostgreSQL, MongoDB, and DynamoDB. That's I want to cover. Maybe fourth or fifth week. I will check what is the timing for that one. Okay. Okay. Now, yeah. Then the virtual environment, sorry, request module, virtual environment, and very basic example of app in Flask and Django. Because if we directly start with the bigger program or bigger things, it will be too bit complicated to start with something big. Instead, just start with very small and then slowly make it big. Okay. Now, we'll start with the variable scope. Now, what are the variables? If you follow the last class, by now you should know that. If you don't know, don't worry. It's just that you want to store values temporarily in the memory so that you can use it for any operation, maybe printing in the screen, maybe doing some calculation. We need variables for the reusability purpose. Okay, store a value in memory and reuse whenever you need it. So that is the requirement of that. Now for the particular requirement of storing data in memory, and we're using the variable to store it in memory, so we can recall the data using that particular variable that you assign, or the value, the key that you given the value, like that you can assign. Okay, now uh, global scope. Okay, so any variable that is created in the main body. So if you have a Python script, for example, let me just, maybe it's better to show you instead of telling you how this, conceptually. So yes, see, for example, let's go to the so yeah, this is also fine. So this is, for example, let's say I'm defining a variable here in this, say say temp, or say something, say variable, for example, x, just assume that one equals to something. Okay, now this is, I'm directly defining inside a say Python file. Okay, it's hello world.py. I'm defining here. Okay, now this is a global variable, because if you define that inside any function, or say inside any loop or something like a code block, then it will not be a global function. I mean, you can certainly make it, I will come to that, but uh, this this one actually defined at the main root level, or say script, say main level. Because see how we define the label, we give tabs, right? So in Python we use tab for code indentation, right? And say code blocking. Now inside a tab, the moment you're giving, that's becoming the local scope. Okay, you can make it global, I'll come to that, but by default it should be a local scope. So for example, I'm writing a function, say def test. Okay, now for example, let's see one particular, let me episode 2, say one example I want to show you guys. Nested function, for example. See, for example, let me copy this function and let's come to the hello world. I will remove from the hello world later on. So I think hello world here. So for example, see, we have, this is a nested block. Okay, sorry, this is a nested function. For example, I will come to what is nested function and all that. Okay, let me zoom a bit then. Hopefully this will be good. Yep. Okay, so for example, here you're defining x. Okay, this is global, but the moment you define x inside a function, say x is equals to some, some value that you assign, it's becoming local variable. So anything that you are defining, any variable, okay, outside of any function or any code blocks, that's a global function. Sorry, not, it's global variable. Okay, that's I wanted to explain. Now let's come back to the slide again. So you understand by now what is the global scope? Any variable that is created in the main body of the Python code outside any function called global variable, and this scope of the variable is global. So the variable that we have defined here in the x, okay, that is accessible inside this def grid function. If you do print, print x, right, and you can, the value will get here. Even if you go inside another function and you do print x, the value, whatever, say test, whatever you define as a global scope, it will be available to everyone in the same way. Okay, that's a global scope variable. Now let's go to slides again. Now note that we can create global variable of there is a global function from inside a function as well. I mean, that's what I'm coming now, how you can do that one. So see this example. So while giving, so of course if you see here, this is a global, but suppose I have defined another, say global keyword. You have to use the global keyword, by the way, then y. Okay, or is well, say you can give values also. No, I think you have to define it first, then give the value. Just a moment. Yes, y is equals to, then some sample value. So you can do that way also. So this way you are, see, even though you have defined, like this is one like easiest way to define a global variable. Another way is to, even if it's inside a function, even if it's inside another nested block, say if function, whatever it, if it's not if function, if condition, wherever it is inside any other code block, the moment you use the keyword global and then say that variable name, it will become a global variable. Okay, now even, but remember one stuff, this code block have to get executed, otherwise this will not work. So let me just show you what I'm meaning. For example, uh, just yes, now say I'm printing this variable. Okay, this just commented out this hello world, this is just for demo. Let's try to print the y and let's see what happened. So let's go to the episode, we are already in episode 1. So Python, then give this hello world file name. Okay, see what is the error. If you can, I think you'll be able to see, let me just zoom a bit, I know that might okay help. See here, this particular part here where it's saying global name y is not defined, because why this happened, if we do that x here, you'll see the value. Okay, you'll see the value, see it work, it's printing the test. But if you the moment do y, it's going to give error. The reason being that this code block not executed yet, Python yet not know that this y variable is actually a global variable. That's the reason. The moment this this get executed, then it will work. So remove this part also, just this is just for testing, right? So remove that and let's first execute this function. So greet, okay, say, or say dummy just for testing, right? So dummy, call this function dummy, and I'm not going to supply anything because I'm just testing the y variable as a global scope. So in this function, I'm going to call now. If we don't call, then why Python yet not know that it's a global variable. The moment we execute this code block, then only it will become a global variable. See, some sample value, because the moment the code got executed, Python know, okay, this y variable is actually a global variable. That's why you're even able to get the value outside of this function block. Otherwise, suppose not a global value, okay, what will happen? Is not, y is not defined. So that's the reason, if you want any variable to be global scope, even inside any function, you can use this one. Okay, let me make it back to like how it was. Okay, so now you understand how you can define global variables. Now let's move to the local variable or local scope. So what is local scope? So any variable that is created inside a function, that is a local scope. Now if you see this example here of local scope, so suppose we define a function, say def, then some sample function, then x is equal to 500 and print x inside x, it will work. You will get the print as, okay, it will print x. The moment you try to print outside of this function, then it will get error. So let me quickly show you that case as well, because you need to have a very clear idea about this variable scoping. Otherwise you will see a lot of issues in Python programming. That is the thing. So of course, this one point is very important actually, that when you're defining variable, it's best to just keep the variable to function scope. That's the best practice, not as something. Use the global variable as less as possible, only if it's ultimately required for anything. Okay, maybe defining some constant values is okay for that time. Okay, now let's come to this example again. I'll just comment it down. So def, say test, let's give this function and say print, so let's define x is equals to, say, some dummy value. Okay, now let's print x. It'll print simply that x is like some dummy value. Okay, now let's go and just call this function test. Let's go Python hello world. See, some dummy value is simply printing that one. Now if suppose let's call this function, that is fine. Okay, After that, let's try to print x. See, it'll throw error. Name error, x is not defined, because x is local scope. X is scope to the particular function only. If you try to call the x, or say we trying to get the print the value or use the value of this x variable, it will throw error, because Python don't know outside of the function what is x. The moment you define as global, which is not recommended by the way, then only it will print. Best is actually use the function to all these variable operation and all that. Global only when you require them. Okay, now you understand what is the local scope. It's valid to the inside a function. Okay, no, outside the function you will not be able to call use the value or call the value, what you want to call it. Okay, now let's go back to slide again. Then there is non-local scope, and this is actually a special kind of variable. Let me actually okay, so if you see here, the non-local non-local scope variable that is neither local nor global are the non-local scope. This is very important in the when you define function inside another function, but you want to pass on the value and you want to calculate and get the final value. Those are the situation when you might need this non-local value, okay, or non-local variables. Now, a non-local variable are used in the nested function as non-local keyword. Get used to define that one. So if you see this example here, def outer function where I'm defining say x is equal to local value. Then inside there is another function called def inner function. There I'm defining x as local, non-local. What will happen? Then the value of x will be available to the inside function, and inside function if the value get changed, then it will change the outer function value also. Outer variable value, that whatever we define as x. So x is equal to local value was previous value. The moment we use non-local x and we define x is equal to non-local value, the value will actually get changed. And then let me show you in a easier way. Then it will start making sense again. So let's go back, and I have an example. So for example, variable tests. Episode 1, let's remove that one. Then we have this variable scope. I hope you guys can see it. So yes, see this one, non-local. Yeah, this is the non-local example. I want to save you guys my time as well, so I have already written all that. Okay, so see this function, outer function, and here the value x is equal to local value. Then what happening? There is another inside, which is a nested function. Then I'm saying non-local x. Okay. The moment I'm giving this using this keyword non-local x becoming a non-local, but not a global by the way. It's non-local. That means whatever previous inside outer function or parent scope, whatever the value variable you have, that value will become this. Like this will you can modify, you can mutate the value. Okay. So then we are defining x is equal to non-local value, then printing inner function value of x. So whatever value you have defined here, it will print exactly it is. Then outer function value of x, okay, that will that's okay. First, this is a function, right? So let's actually separate this one. This is the function definition. The moment we calling first this one, this outer function value of x, it will print this one. Okay. Then the moment we call inner function, then only this will start making change. Okay, so let me show you quickly, but we have to call the outer function first, then you will be able to see the differences. So let's go to the episode 2. Let's clear the screen. Now Python, then give variable scope example. Okay, so okay, yeah, I'm using Python. By the way, this is a very easy to do mistake. I should be using Python 3. Okay, but see, by default it's very good error case. So Python dash version. See, it's 2.7, but whatever tutorial I'm showing, it's always use Python 3 plus whatever the latest version you have. Okay, so for that one I say Python 3, and for this reason, to fix this problem, we'll be learning how to use virtual environment as well. I'll come to that one maybe at the end of the slides. Okay, for now let's use Python 3, then this variable scope, and see, first it printed outer function value should be like I am the local value here. I'm local value. This one is actually getting printed, whatever the value you're defining here. Then the moment you're calling this nested function here, inner function, the value changing to I am non-local value. See here, I'm non-local value. And next time, okay, because this is getting printed inside the function. Next, after that one, if we call like outer function value, what is the this variable value becoming after this assignment of the value? That is, I'm a non-local value. What if we don't define as a non-local? So just for example, I'm just saying I'm commenting out the code. Okay, so it's no more this is not getting applied. So what will happen? See, it's printing I am local value when I'm printing say print outer function value of x without calling this function before. It's printing I am local value. Next time I'm executing this function inner function, and now note this point, this line is commented, it will not get executed. It's printing I am local value because yeah, this variable is local to this particular function, inner function. That's why it printed I am a non-local value. The moment after this execution complete, okay, then again I'm printing outer function value of x, which is now this one, because this x is local to this one and this x, okay, local to this outer function. Okay, this is the entire function block. Okay, that's how it works. So the moment you use non-local, it's this function actually it's no more a local, but again not global as well. So if you try to use outside, outside of the function, if you try to call it, it will throw error. It will all work till now here, but it will work here. X is not defined because Python don't know x's value outside of this function. That's why we try to use as a global variable. It will not work. It will error you out. Okay, that's why it's very important to understand the variable scoping while working. Working on smaller or large, medium or larger. Like when you keep working on things, this small things started making bugs. So from the beginning, if you're aware of all this, you might reduce the bugs in the future. Okay. Now let's come back to the slides again. So now you understand what is global scope, local scope, and non-local scope, right? Now let's move to the advanced functions in Python. And to be honest, the depth I have covered, it's not depth of what the Python has to offer. Python has a lot of other advanced thing, but these are the kind of advanced, but kind of a basic level advanced. Because if you try to give you more complicated scenario, you might see overwhelm. Okay, so my intention giving you common use cases of this advanced Python, so you get aware of it, and in later on we'll definitely we'll learn more advanced as we go through it. Okay, now. Okay, yes, so here next is this advanced function of Python. Here first thing is document string or docstring. So what it is, so when you write Python, okay, when you work for a bigger company or medium level company, not for the smaller companies to be honest, you are required to do documentation at the when you're writing it, because otherwise if you write a pull request, high chances they will reject the pull request. They will say, where is the documentation, what you have done in this function, what is the parameters, what is doing, and all that. Again, small companies doesn't require that, but medium to they will require it for the medium bigger companies. Okay, so just simply you can see this example here. How is the docstring? So inside the function, so dev greet person, say I'm giving three commas, see, and not commas, three quotes. So opening three quotes and ending three quotes. This is how, like, this function greets someone. Like, this is just the documentation part, what the function does. Okay, this is how you can give it. Now the next one is that now if you want to see, there's not much to see. Docstring example, I have it. This is I think I didn't read a docstring example because see, this is just simple. Okay, it's mainly three codes. That's it. Even when we go for the advanced programming, I would say documentation. When I show you the in future classes that debugging and all that, I'll show you how to add all that. Okay, for now you can ignore. Okay. Now. What is the anonymous and lambda? And to be honest, by the way, I'm using this lambda function a lot for my current projects. So what it is? I'll come to that. So in Python, the function which don't doesn't have a defined name is called anonymous function. And in Python, anonymous function are defined using the expression or using the keyword lambda. So the moment you are writing a function without giving a name and you are using a lambda keyword, it becoming a anonymous, or you can call it a lambda function. Okay, and easy example, let's do some example here. So do sum then equals to lambda, it's accepting a b, then in the function body part it's a plus b, and you can in the do sum, this is the variable definition where you are getting the value here. Okay, so do sum is equal to, like, this is the function, but actually let me show you in the code, that will start making more sense in that way. Okay, quickly let's come to the lambda. I am sure I have a lambda example. Anonymous lambda. See the easy example here. Now this particular function is not actually lambda. This one is lambda. Like this is, I'm just showing that this is like this function equal to this two-line function. Instead of lining, if you just doing smaller operations or inline operations, is instead of having a defined function, you can just simply use like this. So lambda, the keyword that you're utilizing, then a and b is accepting parameters as a and b, then you are giving the a and b. Okay, so let's quickly do that and see this is how you're doing it. So print do sum, then 10 and 20. So this is the lambda function do sum, where you are giving 10 and 20. So this is the two parameter we're expecting like this, so a and b, right? And here is simply like what is doing. So this is the main function body where it's doing some certain stuff, like it's doing some, you can do say some string operation, whatever thing you want. In future I will show the many use cases, but now for just think about we are doing sum in single line. For that I can use this do sum lambda function. So in do sum function we are supplying a and b, which is 10 and 20, and will print the value. Okay, so let's run it. Python 3, make sure that you're using the proper version, by the way, otherwise you might get error just like I got last time, like this one. So Python 3, then anonymous, this one, this I will get a function name, sorry, file name here. I see it's printing 30. So this is a easy way to integrate lambda functions, and this is actually useful in many cases. Okay, so it's a good thing. And if we see here, I think here also another use case. Suppose this list filter example. So I have say 1 2 3 4 5 6, a lot of numbers, right? So here's a filter any value that is greater than 5. Okay, so let's have that one, and this is just another example. Okay, so if we do print this, I mean if we just execute this function, see it's printed. So we had this 1 2 3 4 all that, right? We created a lambda condition, that list filter, and using a lambda function as a filter, with checking if x value greater than 5, then only put the value inside this new, I mean not new, say existing variable only, just put the value there. Oh sorry, no, I'm using new variable. So whatever the, I mean this is the value you're passing, then lambda taking the value and then converting, like checking that okay x equal to 5 or not. If it's greater than 5, then only it's get added in this particular list. That's what happening here, simple case. So if that's why when printing, because of this condition, it's 1 2 3 4 is not getting added here. You can see example here, only 6 7 8 9 10 got added. So this is just another use of lambda function. You might see countless example. You would be fussy if it can be done using simple way, go for the simple way. Ultimately if it's lot of logic you have to put inside another function, then you have to go lambda is for one liner. I will suggest for bigger function you should be using normal functions. Okay, and normal function also there's a lot of things, I will come to that, but this is a very good way to start. Now, next is the recursive function. Okay, so what is a recursive function then? A function that call another function, but it should be call itself. It's a recursive function. It can call another, but usual cases it should be calling itself only, so that it will keep going on and on and on till if you have a condition to exit out of the particular recursive function. Otherwise, there will be memory issues. So, for example, you have written a recursive function and you forget to exit out of it. It will keep running and running and running, and you will keep utilizing memory, right? And will do memory overloading. Ultimately, you see no memory space left in the memory for OS to operate, and it will die. Okay, so we don't want that to happen. We want that there should be a exit workflow. For example, if you come here in this function, I mean, let's just come to the coding screen. That makes more sense. So recursive, I think I was watching this recursive. So see this one. This is a recursive function. Let's clean the screen as well while doing that. So this is a factorial calculation, and we did this factorial a lot in our school days, in college days, or even while learning programming. So nothing new to explain here. The main part here, see, there's a, I mean, this is the calculate factorial function, and you are keep calling this calculate factorial. And see, the moment, like this is the, always remember the logic here. There has to be an exit way or break the particular function. Otherwise, if it keep running and running, it will be a problem. Factorial calculation, it's very good use case where you just use the same function to calculate the factorial. But always make sure, suppose you missed just this part, then it will be a disaster. So just I'm just pointing it out there. Okay. Yeah, just let me execute also, since I'm showing you. Why not just execute it and show you? So recursive example. See, factorial of 4 is 1 into 2 into 3 into 4 is equals to 24. Now, this is one example. You can think of such use case that is suitable for you. Okay. Now, let's go back to the slide again. So you learn what is a doc string, is for adding documentation, Lambda, one-liner function for quick operations and all. The recursive function, a function that's called itself. Okay, factorial calculation is one example. It can be, processing. So suppose a very good use case I used to do a long time back. Now there is better way. So in database we have, for example, 1 million record. Okay, if we try to process, and we have to do something with all the data. Okay, now. For example, that I have to process all the data, but if I call all the data, 1 million data in any memory or any system, it will bound to crash. It will be hell slow. Okay, and we don't want that. We want our system to be very, high performant. So what we can do is that we can make sure that slowly or chunk wise processing. So first process, maybe 10,000 record. If that 10,000 record process, then call next 10,000 records. In those cases also, at the beginner level, if you think you just to improve your thinking way of doing programming in Python, you can do that kind of processing, like 10,000 process, then go like call the same function which process something for next 10,000. Keep doing that till it reach the maximum number, then exit from the function. Okay, or just add the condition. If you don't no more call the function, that's the exit point, right? So that's the one very good use case of like database processing or data processing in a say recursive way till it reach the last record. That's one good example. There could be many. I'm just giving you a thought for some ideas and all. Okay. Now let's move to the next of this advanced function. Again, the things that I'm covering is pretty basic, advanced level, pretty basic. There are more complicated scenarios which we'll be covering as we move forward. Okay, next session onwards. For now, but this is the kind of basic building block. If you miss this one, that thing what I explained the next week will be a problem for you because you missed this one. Okay, now what is the nested function? So a function defined inside another function is called nested function. If you see this example, like dev greet, then there is dev greet first name, then this is like, I will actually maybe show you in the code. That's more visible or more looks good. So nested function example, see this one here. So see def greet name, this is the like one function, this is the global function, not global function, You can call it global function, but say it's a function, normal function. Inside greet, there is another function. Okay, we call it greet first name. So, and then after the function definition done, I'm calling the greet first name. So ultimately, it's simply calling this one. Okay. Now, in the moment I'm calling this main function, like you should not directly call a insider function, right? You use the main function to call whatever operation you're doing inside that particular function. Okay. So for this example, in the greet main function, I'm just printing the first name, say Sandip, for example. Now, what is happening? This is the main function, and any function that is defined inside another function, like this one defined inside greet. So this particular greet first name function, or inside another function, whatever function you write, is becoming a nested function. Always remember that. Okay. So nested function is nothing, just a function defined inside another function. That's a nested function. Okay. And now if we just simply run the script, Python 3, then nested, you'll see it will print like greet Sandeep, say hello Sandeep. That's it. Okay. That's one easy example of nested. Now we can of course make it more complicated, and we'll make it more complicated. So let's make it more complicated use cases. Now let's come to the closures. So what is the closure? Python closures are the nested or inner function that are enclosed within the outer function. And I will explain you what is this enclosed within the outer function meaning. Let's go through the definition first. Closures can access variables that the parent in outer function scope. Okay, so whatever, so nested function, you know that, right? Parent function, inside parent function there is another function, that is a nested function. So whatever the variable you are passing in the main function, that variable can be accessible inside the nested function, or say function inside another function, that one. Okay, that's is the closure, and I will show you the closure here. And not just that, by the way, closure in the sense that the variable that you have supplied in the main function and getting passed to the inner function, that will stay there till you call it. That is the closure. Otherwise it will become a normal what is the difference between nested function and closures? Nested function all executed, the inner function also executed, and there is, you're not returning the inner function, but in the closures you are returning the nested function so that it can be reused somewhere else, and whatever the value you have passed to the main function, okay, or the parameter you pass in the main function, it will be still available in the inner function. Okay, and I will show you so that it will become more clear. Okay, see here, this one is that closures. Okay, closure example. Now if we see here, this def name, okay, and that diff name here, inside that, let me just reduce the, so cool now. Better. Okay, so def greet name, you understand, it's the outer function. Then inside that there is def greet first name. Now very closely look at this function. This is a nested function. Okay, but if you noticed, this greet, the function, the parent function, we are passing one variable. This one is the variable, this is the value part, this is the in function definition, this is the variable name. That name is getting passed to this inside function, like, so they've greet first name, there is print hello, then the first name. So this what you have passed in the parent function is getting passed to the inner function or the nested function. Then so but see here, we are not calling, in the another example we are calling the greet first name directly after defining it. Okay, we are doing that, but here in the closure we don't do that. We just call the parent function to get the child function or any other final function out, and in that function we have all the parameters that we have supplied in the main function or the parent function while assigning or while calling that parent function. So here if you see, this dev greet actually returning this function. Dev is a greet first name. So the moment you're calling greet, then in the parameter you're passing in the name as Sandeep, then it's coming to here, it is not getting executed. If you do this only, it's get executed, but if you remove this is parenthesis or say first brackets, it will not execute, it will return this particular function as a kind of a variable. Okay, so we call this function parent function and it returns this inner function, and we can call this inner function anytime, and still whatever the value you have supplied while calling the parent function, that value will be residual value, or it will still exist inside the inner value. That's why the moment we are calling greet Sandeep, then it's creating is applying with the inner function, and there we have the value like print hello name, right? So we supplied name while calling the parent function. Now the moment we call the out, like this get greet first name is getting returned, right? So we have it here, and this is still variable, okay, but it returning a function, right? So since it's returning a function, you can call this function by adding the parenthesis at the end. Okay, so let me show you, then it will start making more sense. So Python 3 and then this closure example, see it printing the hello Sandeep, because yes, you can say more of the, if you go from the C Shisha background, you can have a pointer reference. So it's storing the value in the memory with this function name. Okay, when you're creating a variable, so in this variable definition, like variable memory itself, this inner another, like this is the inside how it working. So it's working in the way this function variable, this is ultimately what happening. This function actually getting generated a new function. Okay, this is not same as this. This is generating a function where this name actually contains the value that you have defined while calling the parent function. That's why then when you're calling greet Sandeep, is returning that function to this here, the greet first name, to inside this particular variable function. And since this is the function that we have returned, we can call as a function. That's why it's giving hello Sandeep. That's how it's working. Okay, this is called closure. Okay, and see, as we are moving, it's getting more and more complicated, right? That's should expect, getting more new use cases, more complicated, right? And this is actually, to be honest, this is not so complicated yet. The things that we work on daily basis have so many other complexities, of course. So that's why when I do the functional programming or API development, you will see what you're learning today getting so many places getting utilized. So learn today now, so that concept what you teach in the next classes will become more easier. And if you still have a doubt in this closure or recursive, feel free to let me know in the comments. Okay, now let me go back to the slides, and I will also do one thing, like after this function part I will see for any comments, any doubts and all that, I will come to that. Okay, so next one is the decorator, and I think this decorator function, by the way, one of the very most kind of function concept you should always keep remember, because while working with any framework in Python, this concept play a huge role. Okay, that's why I'm insisting that much to always remember this function. So what is this? A decorator. And what is a decorator, by the way? A decorator is a design pattern in Python that allow us to add new functionality to an existing code without altering or modifying the function structure. So for example, you already have a piece of code, okay, or library for example, and you got a task to not change the existing code. Instead, you add a layer in the code, okay, so that you keep adding the function, improving it without changing the main source code. Can you do it? Of course you can do it. You can use decorators. It's used to enhance one existing feature. Okay. Now, this decorator acts as a wrapper. Okay. And it is also called a meta programming because a part of program tried to modify another part of program during the compilation time. Okay. And use cases like authorizing Python web frameworks is Django or Flask Django. That's why while covering Flask and Django, it's so many places will get used. Okay. Then logging and execution. Suppose you want to track the logs and all, and it's not just that. There is the execution time tracking. What will like in upcoming session when you do performance tracking and debugging and all that, you'll see this decorator playing a very important role there. Now let me show you in more practical way so that it will start making sense to you guys. Okay, let's come to the code now. Let's see, we have this example, decorator example. Now notice this function very well. Okay, so see, it's a format grid. Okay, what it's doing is pretty basic again. So in format grid, we are passing one function. Okay, and this function, whatever function you pass, it's we are defining a def inner function. So what's happening there in inner function? Again, we are like say we expect it's a name. Okay, so in this name you give a value, and whatever function you supply as a main parameter, that will pass the name. So for example, you have a variable, you have a function which expects a parameter as a name. Okay, so what you're doing, simply we are passing that particular function as a parameter, and we are defining another function and calling that function inside another function. Okay, now I think it might be looking a bit complicated, isn't it? So let's simplify it even further. So this one, we have def greet first name, and if we call this one, for example, let's try to call it so that it will start making sense that way. So Python 3, let's see that if I just comment it down also, and understand this concept very carefully, because we'll be using decorators in all over the Python API development. When we do the API development, defining the routes and all that, when we do performance tracking, we'll be using decorator. So understand that the very basics of this decorator first. Okay, so for now example, we have this very basic function that is greet first name, and if we call Python 3, then decorator, what the function, that Python file name, it's saying that first name missing required. Oh, okay, I forgot to give the name, so let's say Sandip. Okay, now it's printing hello Sandip, isn't it? So let's make it even better. How can we make it even better? We will say this one. So this time, now enable this function so that it start making sense. So instead of like what is printed, hello Sandeep, right? If we want to maybe look it more better, I mean, this is for example looking better, you might be want to do say pre-processing, maybe you want to remove the extra spaces, trim it, maybe you want to store the value in DB and maybe check the value exists in DB or not. You can do any kind of checking or formatting, whatever you want. And for example, here I'm adding this one as to keep it simple, but you can do real life stuff with the function. Okay, so I am going to pass this greet first name inside this format grid. So in this format grid, what happening? So the moment I like, this is the function. Okay, inside that function I'll be passing the greet first name, then it will go inside the function and it will return what, the inner function. So whatever the function we give, it will give it the inner function. This one I will get return. Now this is not getting called, so the moment you want to call, you will be calling this inner function. So whatever the variable, say output of inner func, and this whatever output of inner from this function you get, you can call it that then. So out of inner func. So this is the final calling procedure. Okay, so first you are passing this particular function to this decorator function, where it's expecting itself a function. Okay, and then we are giving, say we are defining inner function, which then like passing this name, and simply you are calling whatever function you supply to the decorator, it will then recall them. Okay, but you are doing all that inside another function. Okay, because you want to call at the end of the processing, you want to reuse it. I think enable that. I think this will start making sense by this way. So what happened? This is the main function format greet. Here what you're supplying, this function where this the greet first name. This is a function that we want to be decorated, okay, or we want to be enhanced. So we are supplying this function inside format greet. So this greet first name will first come to like in this particular phase as a parameter, then it will come to this particular place as and see all stored in memory, by the way, like because it's the function getting called, right? So that's function, and we know that this function expecting a name. So that's why we are like this inner function is actually expecting a name where you are supplying the name. And see, since we are not calling inner function inside the format greet, we don't need to supply the name because this is just a function definition reference, right? We don't need to call it, we're just simply returning it. Whoever want to use this format greet function final output, that is inner function, he have to supply a name, otherwise it will throw error. Okay, so that's why while you use this format greet and supply the greet first name, it return this inner function as pretty greet. And the moment in the pretty greet, if we don't say, we don't give this one, okay, it will give us error. It will say, okay, missing one required positional argument, right? So that's why you have to give the first name, and then only this pretty greet, which is ultimately is this function, will call, and what we are expecting a name. So this function ultimately here we are passing this name. So pretty greet, then the name Sandip, and what will happen? Of course, this function ultimately this is what is getting processed, right? This will get called, but before getting function call, we are printing something pretty. Okay, so let's clear the screen first and see, it will look better now. See, so what happened? We created a function. We created a decorated function using this decorator function. We supplied our function that we want to be decorated. So it goes to the the decorator function, then its inner function, the function got enhanced, it got more features, then we return the inner function or nested function, then we got the by calling the decorator function, we got the inner function, and we are calling the inner function, which is the enhanced function, enhanced version of the function that we have supplied initially. Okay, now it might at the beginning be a bit overwhelming, but even if you keep working on and working on, it become easier. This is more of a practice. If you do, then it will start making sense, by the way. So this is a complicated way. One more easiest way to call this decorator function is actually this one. Use this at the rate. So at the rate format greet. So this is the main decorator function. You don't have to first pass it, then get the output and then call it. Instead, just simply wherever your function definition is, you can simply give it there. Just add like this, your function definition before, just add the format, and that's all you required to make it a decorator function. Now if you call it, let's see, it will still print like this. So this is the right way to use the decorator function. Now let me see all the comments in LinkedIn as well, if anyone have any doubt. Now see, the problem is that the streaming software, I cannot see the LinkedIn comments, which is the most negative part, by the way. So what I'll do, I will simply go here and we'll check it. Okay, let's see. From Singapore, trying to years, can't get, okay. Warning, how long the session will be. This session will long, maybe another 30-40 minutes max. Okay, session will be recorded. Yes, it will get recorded. Joining from Lucknow. So I don't see. Okay, now no issues. We can if you have any question, feel free to ask on LinkedIn or YouTube. Fine, I will just check. Okay, so we'll now learn this decorator function as well, which is to enhance another function or add features to any other function. Okay, and it will be getting used a lot in upcoming, even in today's session also. While I explain this Flask and Django, it will be useful there. Okay, now let's go back to the slides again, and we learned about decorator function. So what's next? Next about this Python classes. Now why classes? See, in in Python, not just in Python, any, if you see any standard top level programming language, what are those? I mean, Go, there is JavaScript, I think there is Java, whatever you want to call it, top level languages you can use these days. Class are the basic building blocks of this programming languages. Why? To promote do not repeat yourself concept or dry concept. So what is that? So if you write a Python function, if you write a class in Python function, you can reuse the this class. What will have it? You will have parameters, will have method, this like functions in easy way, and you will have everything kind of all the functionality. You write all the logic in class, then use that class in multiple places whenever you need it. So you are writing code once, then reusing the reusable function, methods, whatever to call it, in other places. That's why function is required. So let's go with the definition a bit, and then we'll see the use cases, how you can write function, and we'll go through all that. So what is Python classes? So, and why use the Python classes? So one of the popular approaches of programming is creating objects. So you have a class, you create an object out of the class, and then you can use the object to call different methods and all. So, and this is also called object oriented programming, and Python is actually object oriented programming language. And whose one of the key objectives is to use classes to utilize reusable code as much as possible. And this is what we call a dry concept. So do not repeat concept. A class is like a blueprint for creating projects, which is true. I mean, a class, you have a particular outline structure, and you can create object from them, and then you can call objects methods to get things done. And I will show how to get things done. Okay, then what is an object? So object is a instantiation of a class. So it's a kind of a copy of a class, but separated from the class itself. So you will have all the properties, you will have all the functionalities of a class, except it's not a class. It's just an instance of a class. So you can use. So if you have one class, then out of that class you can create multiple instances. Okay. Now I think if you think about our classes in the room concept, classes is kind of same. So in a class you have so many students, you are teaching, like student giving all the same education, same facilities, right? And one student can access to the class and get all the facilities. So class is where you have all the methods, all everything, all the constituent, all the facilities. A student going and utilizing the class resources. So this is the same. You're creating like objects are there, kind of instance of a class, and just using the whatever functionalities have in the class itself. So an object is the instantiation of a class. In simple term, an object is a collection of variable and function that act as the provided data defined in the class. So whatever thing you have in the class, you defined it, you're just creating a copy of that, and you're storing in an object. Okay. Then so, and note, whenever an object call is method, the object itself is passed in first argument. That also will come. For example, we have here, say def init self. So first parameter should be always the self, and then the next whatever the additional parameter you want to supply. Okay. And we'll come to the constructor also. So this constructor, nothing special. Is just that when you start you write the class, you can write this init. Okay. And in this init you can pass on the default variable. So kind of the variable you might want to get accessible throughout your object. Okay. Or maybe just throughout your class, what do you want to call it. Those things you want as a constructor. Now I know it's start making sense again the moment I show you some demo, and we will show that. One question is there, so let's ask that: how to decide which function to use? I think, see, it's all about the use case. If you have a requirement to optimized further any existing code base, then of course use Decorator. Suppose you need to write many small function inside another main parent function, then do so that you don't to repeat yourself. You're using your codes. In those cases, you want nested function. So all about the requirement. If you have the requirement, then only you will be using it. Okay. Now let me show you the demo on this class. Then this will start making sense. So let's see the class demo. So yes, let's define a very simple class first instead of going through all these complicated parts. So we have this class, my simple class. Okay, and in this class we are giving x is equal to 20, and then defining like print the value of x, which is and the c, the very first parameter. This is we are defining say function inside another class. Okay, in that class we have this function, so that if we want to use this one, we want to use like first create an object out of this and then call it. Now we'll come to that. Just like notice this part. Okay, and maybe I don't know how to zoom it, but anyway you might already able to see it. So we're defining class. Don't miss this one. At the beginning, you know, when I was learning, I was making mistake. I always forgot this and these things. So don't do mistake. And maybe at the beginning you might make mistake, but get used to these things. Okay, so class, then the class name, then you are giving some default variables, then you are defining the uh, methods inside the class. So and in the class definition you are writing here, and this is just a very dummy printing. This value of x is this, but if you want to access the value of this particular x, it has to be a self. That's why the very first thing you should supply to your function if you want to access the properties of this particular class is to give the self, which is the reference to the object. Now when it will start making sense? It will start making sense when you have an object. So what you're doing, we are calling my simple class. Okay, we are calling this particular class, and the moment you do that, it's actually creating an object. So say C, for example, C is object, and there you want to print the value. I mean, you want to call this particular function. Now this function is where inside the class, and you are creating an instance C from this particular class, right? Now in order to access the value of this particular function, you have to use the name of the object, that is C, because we define like C is equal to we have the instance, or we have the instance of this particular class as an object in C variable. So C variable, C dot, then this particular function name. And see, even you are supplying self. I mean, we are in this particular function. We are what we're doing. We are passing self, right? But when calling, we are not passing self. The reason is by default, the moment you write self, the class actually pass itself. That's why at the first parameter should be always self, and after that only you should add the additional parameter. I'll come to that why I'm saying that. See, this is in my simple class here. So what if instead of x I want to supply say y? Okay, the moment if you do like this y, it will not print anything. Let me show you. Python, then classes, an object example. See, it's doesn't, I mean, okay, you didn't supply the y also. So let's do that. Say 20 or say 30, something, whatever the value you want to pass. It will still object has no attribute y, because I mean we are passing as a normal variable. Okay, so we don't need object for that. We can directly access it. See, the value of y is this 30. But what if we want to access the value of the like this inside any variable if you have defined that value, then only you need self. Okay, so self dot x, then only you need to like use this particular this way. Say this self is a special keyword that point to the self, or say point to the main class object. So we have created C. So C already have the value of the x is equal to 20. That's why the moment you are calling self dot x, actually calling C, then x is equal to 20, right? That's why we will print the 20 value. This is, you have to understand very carefully, because and practically we'll be writing classes, and we will be using classes to call the different methods and get the compute something. We use this kind of way. The main important part you have to remember, you always pass self as the first parameter, and then additional parameter you can define like this, y, z, whatever you want to call it. Okay, y, z, you can keep on passing it. Okay, so this is what I want to explain about the basic class. Now let's go for the constructor, because I promised that I'll be explaining constructor as well. So construct is actually again not that important, I would say, but sometime based thing, all based on the requirement and data structure, however you want it. Okay, now in order to define any particular class as a constructor, you have to use this particular function, def underscore underscore init, then underscore underscore. This is the way to define the constructor in Python class. Okay, so class, I'm giving name as person, then there I'm defining the first like say init, or so creating constructor. There I'm passing the name and age. See, remember one important part here. Always I'm using self. See, self, because it refer to the object itself. Always when you're writing method in Python class, make sure to always include the self part. Otherwise, you might face issues. Okay, so every time you write function inside a class, add the self as the first parameter. So here also you are passing in the constructor function self. Then I'm passing additional two parameters, which is you can define any parameter you want. I'm giving name and age. Then I'm storing that particular like self pointing to the object that you're creating, so or getting created. So self, then name is equals to the name that you're supplying in the parameter. Age again we are storing like self, the object, then age is equals to the age value that you're supplying. Okay, so this is the parameter, also the variable inside the object, and you're storing the value like this. That's how if you use these values in another functions or any other function, you just say, for example, def get person, again self is pointing to the object itself. Then self, we want to access the name, then you can just call self.name. We want to access this age value, then self.age. This is how easily we can call different, we can define constructor and pass some basic values, and you can reuse them as we want in next onwards functions. Okay, now for example, and see this actually another important concept here also. So see, this person is a class, and from the class you can create as many objects you want as required, and every object will be different, isolated. It will not conflict their own values, because an object is an instance of a class, not the class itself. And okay, so whatever object you create from a class is independent. Its value will be not dependent on the any other objects. Okay, the reason I'm defining, see, I'm creating one variable, that is not variable, also one object from person class. We're giving John as the first one, so that is a name here, because see, self always point to the object. So whatever object getting created using this particular class, that is a P, of course, that object's first name value is John and the age is 36. Okay, then second object that you are creating, that is P1, and P1 again it's creating object from the person class, and its name is Sandip and age is 30. These two values, P1 and P2's variable value, are not same. It's, of course, it can have similar method, it can have similar other whatever the global classes, global, but classes parameter use patient you defined, that could be same, but the thing that you passed, the variable that you passed, this name and age as a constructor, it will not be same, because you passed as a dynamic variable. Okay, because it's a dynamic in nature, you're passing dynamically while creating the class itself, right? That's why John is actually P1's object's name is John and age is 36. Sorry, P's like P variables, P object variables name is John and age is 36. P1's object's name is Sandip and age is 30. Okay, now let me print it. I think then it will become more easier. Okay, so class and object. You see, P1 greet person. So first, like P1 we stored John and age is 36, right? So P1, hello John, your age is 36. And second time we call P1 greet person. So hey Sandeep, your age is 30. Again we are calling P dot greet person. Hi, hello John, your age is 36. So just to make sure that, just to confirm you guys, or to show you guys that the class you create from, the object you create from the class are isolated in nature. Okay, so that's how you can create as many, you can reuse the class as many times as you want, and you can do all the processing. There's a reason in database implementation, there's a reason in many other libraries this class getting utilized. And in production also, when you write code, you should be writing classes, you should be utilizing classes, modules, and all that kind of stuff. And we'll come to all that in our session multiple time here and there. Okay, so this is all about the classes. Okay, now let's move to the next slide when we talk about the class inheritance. Now, what is class inheritance? So in Python, what is a class in Python? In Python, we can define new class with a little or no modification to existing the class, to the existing class. Okay, and it allows us to define a class that inherits all the methods and properties from another class. And the class from which it's being inherited called a parent class, and the class which you are actually inheriting from the class, that actually means the class that you are writing this inheritance part, is the child class or derived class. Then you have the super function also, we'll come to that after a bit later. Let me show you the this in inheritance. Let me show you the inheritance part. So in inheritance part, we'll come to that. Like you can see example here. So we have defined first the class patient person, diff init self name age and all that. You just show it. Then person, then init, all that's there. Okay, let me show you in the example. That will make sense. I think class inheritance. I have created one inheritance example. Just a moment. Decorator inheritance number. I know that I have written one. Okay. See, why is calling inheritance? So here, if you see class person, now this person class, and we are writing as a, like, say for example, this is the first class. Okay, class person. Now in this we are giving init, or you're giving first constructor. In constructor we are saying name and age, just like the last one. Okay, is exactly same. And we have a greet person self, which printing the first name of whatever the value you supply. Okay. Now we are adding a child, or say derived a child class. How we are doing that? So if you see here, then class patient, and inside the patient, by the way, we are giving the person. So person is the parent class, or the class which might have a lot of functionalities, everything. This is kind of a, you see the decorator function. This is a bit different from the decorator. We can call it like decorator used to enhance one function, right? And this inheritance actually used to enhance the existing classes, where you don't want to modification to direct classes, but you want some features of the one class. And you may write another new class out of that old class, and then adding some more functionalities, then it will be a new class, right? But the new class that you're writing from the old class, so in this is patient. Okay, and parent class is actually person. So person has this greet person, had this constructor, it's acquiring that one. So patient, then person, again inside the patient, which is a child class of a person. What you're doing here, we are giving init, we are calling init, and we're saying, say this particular parent function can support up to 2 parameter, name and age, right? Just a moment. Okay, So if you see here that patient class, which is a child class, is inheriting person class or the parent class, that is person. But in the person class, if you see, that can accept only two parameters, name and age. If you give any additional parameter, it don't know what to do with that. If you miss one parameter, it'll throw error, right? No. So what we're doing, we are writing a parent, say patient subclass or child class or derived class, what you want to call it. We are again, for that class also, we are creating a constructor. We have to accept name and age. That is a requirement of the that person or the parent class, right? And then we are supplying the age, sorry, case. And when in this particular function or method, we are first calling the parents init method or parents constructor function. So it will have the name and age, and then self we are assigning the case value, so that when we create an object from this patient class, it will have the value of name, age, and the value of the this case value as well as we supply. Okay. Now we are printing, like say printing dev print case self. Now self, this self or this object will have all the name, age, and case value. So we are simply printing self then case. So let's uncomment these three lines. First, we are creating an object out of the patient class. Patient class is the child class, which parent is the person class. Anyway, so patient, which is the child class, then we have to supply three parameter in the sense, first one is the name, second one is the age, and third one is the case. So first John, then 30 is the age, and the case is the code. Okay. First we are giving calling the greet person, but see, remember, this patient class doesn't have a function called this greet person. This greet person actually is a method from the parent class, that is person, right? But the moment we define patient as a child class of a person, it inherits, it absorb, or it get all the functionalities and, like say, all the methods and variable, everything from the person class or the parent class. Okay. So just like, if you have, wealthy father mothers, you are getting all the assets to you, right? They give it to you. So that's how you are getting all the values and everything. And then you keep working on, you make more wealth, right? So that's why in this particular parent child class is having more features, and we are just utilizing that. So that's why the moment we called let's call this inheritance example. Okay, so it's printing hello John. This function is actually the parent functions, parent classes function. And then print case, this one is actually the child classes or the class from which you are creating object, that classes method or function, right? So it's simply printing patient has a code. Okay, patient's case is a code, that's part. Okay, so now you also understand the concept of this inheritance, and is actually getting utilized in the production project that I work on. There also inheritance plays a big role for the uh, improving or enhancing one classes and all that. Sometimes it become like necessary to change the parent classes as well, but we try to use reuse and add more advanced functionalities from the child classes, sorry, parent classes, using child classes, like just I show you now. This one is a super function. Now what is a super function? So let's come to the slide first. So if you see here, the super function is that Python also have a super function that will make the child class inherit all the methods and properties from the parent using super function. We will not have to use the name of the parent element. It will automatically inherit the method and properties of the parent. Now let me show you again, showing make more sense. And I think I will just do one step to reduce my screen. I don't want to be on your screen, like block the field of view. Let's clean this. See here, here we are giving what? So we are using super patient person. Using super function, we do not have to use the name of the patient. It will automatically inherit the method. So just simply see here part. We are creating, when this one, Let me enable this again, so it will start making the sense. In this case, we have to call this person underscore init, right? So what we are saying, we just don't have to use the name. You can just simply use the super function. It will automatically get this, like it means that it's a parent class. Okay, that's how also you can pass on. That's the only part here. Nothing fancy. Just instead of, don't have to use the name, just use the super. That's it. Okay. Now let me comment down all these things. Now you have idea of what is the class, what is the inheritance of the class, and all that, right? So now let's move to the next topic. Next is the I think Python class inheritance we did. Okay, there is a bit more of, I mean, you want get the idea of inheritance, right? But in Python you have a bit more advanced functionalities, like multiple inheritance. Okay, so what is multiple inheritance? You can see this example. Let me quickly make my screen uh, a bit smaller. So okay, if you see here, multiple inheritance. So if a class derived from more than one base class, that is called multiple inheritance in Python. So previously in our example, we are inheriting or we are defining a person as a parent of the patient, right? Here, if you see, you can if one class actually derived from multiple classes, so it's multiple parents. Okay, for example, here class multiple inherit example have like simple base, like we have two classes, simple base 1, simple base 2, and you are passing both the classes as the parent class of this multiple inherit example, which is the child class. Okay, you can do that. And next one is the multi-level. So this is like you're supplying both two. Now if you want to say you have written one class, okay, then you are writing another class to enhance one class, and you're writing another again inheritance to, I mean, another class to enhance the feature of first class and the second class that you have written. So parent that have a child, like your grandfather have your father, and then your father have you, right? So that's the multi-level inheritance. In Python class can have this derived class, which is a multi-level inheritance. And again, it's all based on use cases. How is the use case? We should define that. Okay. Example I also have here. If you want to see this one, multi-level inheritance, just pretty basic example how you want to do all that. It's again all are based on use cases. If you want, you can check the use cases. Now I'm just skipping the demo because this have nothing special to show. This is just the use case base. Now, what is the next thing? Let's see. Next is the Python package. I think Python package is one of the most important part, by the way. So what is this Python package? So Python package is actually the package in Python is simply a directory with Python files with a name in init, like underscore init, then underscore dot py. If you do that way, it's a package in Python. That means every directory inside the Python path which contains this file name init dot underscore init underscore dot py, it will be treated as a package in Python. Now a package can have sub packages and modules. It's a way of organizing or well organized hierarchy of directories for easier access. It's just simply you have a say lot of Python files. You want to create a package out of it. So kind of have proper hierarchy to maintain on for the modules or for the classes and all. Then you have this package concept there. Okay, and this package concept is actually very important. If you think about, you download all using pip, right? So there also, if you see the source code, there are a lot of packages. Okay, so this is important. That's why. Let me see if I have the package example or not. Yes, I have one package example. Let me show you. So if you see the code, there is a should be a package example. So I mean, yeah, I think the important part is actually how to call and get the packages features, all the modules and all that. So let me just explain the package first. So we have a package called greeting. Okay, and this package have Python files. Okay, but it will not become a package till you mention like this underscore, and this is a blank file by the way. Just write this underscore init underscore dot py, and that's it. It will become a package, and in that you have a patient. So in patient you have say init py. Okay, so this is sub package, and there you have this module, for example, which is I'm calling greet.py. Okay, and then we have say hello, say welcome. Similarly, in patient a person also we have underscore init, so it's a sub module where we have this say hello on a single function. Just you can have any code. I'm just giving example. Student also init py, just to make its sub package. There you have this module say hello student. For that's how we define. Now we have multiple modules. We call this greet as a module for different packages, and entire greeting is actually a module. Now how you import the resources and call it, that's the important part. So in order to utilize this greeting package, check this example, this package example. See how you're importing. So if you want to import a module from a package, we can import like this way. It's all folder structure. Okay, first the main package name, which is what the main package name is actually this greeting, right? So see greeting, then inside there is what is the next sub package, this patient as a person, right? And inside that there is this greet module. Okay, so we're importing this greet module, and how you're doing that, import greeting dot person, so greeting folder, then not person folder, and then the that greet file name. Okay, and how to call it, I mean this is a very ugly way to call it, giving like calling greet dot person dot greet then say hello. Instead you can use alias, for example here. Okay, so greeting dot student, like again greeting then student folder and dot greet. You see how you're using alias as greet student, and then you can call it like greet student dot say hello. This is more cleaner, right? This is how we can utilize, I mean, you can import the different functionalities from one package into maybe some other places. Okay, now if you want to import a module without package prefix, you can do that. So from greeting dot patient import greet. Okay, so you can see here since we're importing the greet, which is again, so import person, then patient, then this greet.py, it's a module, right? So using we're importing module as an alias kind of way, and then we are calling it that. And but it's not just that, you can just import the function part only. You don't have to import all the modules to offer. You don't have to import the entire package. You can just, if you is the requirement only limited to the function, you can just call from greeting, which is this folder, then there is patient, which is this folder, then there is greet, which is this module, then there is say hello, which is inside that particular greet module, there is a say hello, this one. So this is I mean in practical life also you will be using this packages a lot. You'll be importing a lot of packages, but you have to know how these things works, what are the behind the scene happening. That's why basic idea about the packages, how you define the packages, how you define, I mean how you create classes, how you utilize classes, all is required. This session was actually basic building block of that, all the concept you will require in that state. Okay, now what is the next one? Next is file handling in Python. Okay, and this is actually a very good one, because in Python you'll be handling a lot of files, maybe log files, maybe CSV files, maybe just some plain text file, could be any files. Okay, now a file, like, what is a file? A file is a named location on a disk to store information. Now, file used to store data permanently on non-volatile memory, such as your hard disk, SSD, whatever the disk you have. Okay, just so that if you boot the machine, it's not get deleted. Those kind of thing. Okay, now I mean, it's not actually not truly the right way. It's just that some solid hard disk drive, it's a solid drive or any drive at all, pin drive, be it, I don't care. You are just storing the file completely. Okay, and it's accessible. Now, what file operations support in Python? You can have, like, you can create files, you can read files using Python, you can update files using Python, you can delete files with Python. And you can see all the, this is pretty basic. You can see this open a file. Then what is the file handling for? First, you have to use by like use Python, that open function. So open, then the file name, and then what mode you're opening. So there are multiple modes. So for R for read, A for append. So you want to append some text or some content in the file. Then open in append mode. Write mode, if you want to open a file in writing and create a file, it doesn't exist. So if the file doesn't exist, it will create automatically. Then in the text mode, so kind of default mode just for reading. B for binary mode. Okay, so let me show a very quickly example on that, all this file handling. So in this file handling, we'll be seeing this operation. Let me quickly cover that one. So let me come to code, and this one is actually file handling. And this is, see, I don't have to go to very depth. You will have all this code example. You can just also run. Notice part, the flow part, I want to cover a bit. Here is the flow, how for the read flow. Okay, see, you're opening a file in the using that open function. Then give the complete, if you want to give relative path, you can give. If you want to give the complete path, you can also give them. And this is the part where you will be giving what mode you're opening. Now, what are the modes? If you come here, see, these are the modes. So read mode, append mode, write mode, then you have the create mode. All the modes are there. Okay, and you can actually like select the mode that, or sorry, use the mode that you want to open it. Okay, and this I've given example also there how opening it. And if you come to the code part here, there you see, suppose we are reading. So I'm opening this file in the read mode, and then I'm just f.read. So this object that is created from this class as a function, I'm using this f.read. So this read will print all the text or content we have in this file. Okay, and then of course make sure that once you're done with all the operation with the file, you are closing the file. So that's you have to make sure. Okay, this is one example. Then suppose you want to read by full path, just like I was telling, I'm giving relative path. If you want to give full path to the file, you can give like this. There's some way. Suppose you want to read specific encoding, so you can also do that like this. Mode is read encoding. If it's a particular encoding, you know what is encoding is, you can use that one. You want to loop through, you can also do that very easily. If you want to make sure that the file exists or not, that is also you can do like this. And we'll be using OS module for that. What is the OS module? It's come with the Python by default, kind of a system module you can say. So you don't have to use any pip or any other tools to install from external sources. It's just that by default is come with. So how to check if the file exists or not? So we will check by os.path.exist. Using that we can confirm if the file exists or not. Okay, that, and we can read it and we can do all the stuff. This conditional part will be using. So when we move forward to the functional programming for log processing, performance automation, you'll be using a lot of this kind of OS commands. Okay, and let's quickly go through the write also, the write use case. So write use case, see, again same flow, work in the append mode if you want to do, like, keep adding some content. Okay, and just make sure like calling f.write. So whatever content you want to write, you are using this method is write function to put there. Okay, and then after you're done with writing, you simply close that one. If you want to write and read, okay, so here you see, open the write mode, and then now what is the difference between append mode and write mode? If you open in append mode, it will, whatever content you already had, it will just add to at the very end. Okay, but here if you want in write mode, it will override whatever content you have. It will just override all the changes. Okay, so make sure when you're writing with Python, make sure, do you want to append it or do you want to remove everything? In use case, I'm saying if you're refreshing some data for one use or say one example. Maybe you're fetching API response, you are rewriting all the contents of one file. Then it is the write mode. But if you're doing log collections, you're collecting some log via Python, some other classes, and you're maintaining one single log file. You keep adding at the end, keep adding at the end. Then you should open in the append mode. This all based on the use cases. Now this is just for the write. Also you can use the delete, and this is actually pretty easy. Now for delete you will use os that os module. So import os, then first check that path exists or not. So os dot path dot exist, then check if it exists or not. If exist, then remove it. If doesn't exist, we'll simply say error, that file doesn't exist. That's it. Okay. This is the file operation in Python. Now let's come to the slides again, and let's go to the next one, which is Python directories. So what is this Python? I mean, we deal with file, we can deal with the directories as well using the OS module. Okay. So what are the directories? A directory or folder is a collection of files. So what are the files? Files where the file name, location, object this is stored on disk and have some information on data. Right now the directory is collection of files or directories. One directory, we'll call it a directory if that directory we create as a directory, of course, then that has multiple files and other subdirectories. Okay. And how to handle directory or the subdirectories in Python, we'll be using like this like OS module, and this different like say this. For example, if you want to change directory, you will use os.chdir to change the current directory. Then if you want to list directories, we can use the import os, that os module importing, and then we are calling os list dir. That way you can list the directories. Now if you want to see the current working directory, you can call os.get cwd, what is the current work directory. And if you want to create a new directory, you can call it's like this one, import os, just like you're doing, then mkdir, then the directory name. This is one way of do it. Now let me in the code again. This is pretty basic, so I will just give a quick example here. If you see here, os, this is the current. For example, I'm running this particular command to get the current working directory. Okay, so let's run it. This is directory example. So Python 3, then directory example. Let's see, sprint current working directory, user Sandip Das, Python for cloud episode 2, that I had written a long time back. So this is way of using OS libraries for all kind of file and directory operation. You can easily utilize this one. Okay, so for example, this is how I move to logs directory of my MacBook logs, and then change to correct what is that. I mean, I'm checking what is my current directory, and I want to fetch some logs data. I want to show, I can track all that, I can do all the stuff. Okay, this is the basics of this directory handling in Python using OS module. Now next one. Okay, I think this is this should be one of the most important part. Okay, so what is this? It's about JSON. I mean, as developers, okay, we will be using JSON a lot. So what is JSON? JSON stand for JavaScript Object Notation. And what is that? So this is just a moment. Okay. Yeah. So it is a human readable lightweight data interchange format, a syntax for storing and exchange data. So its main purpose is actually store data and use, like, send and receive the data in this particular format. Okay. So it is commonly used for transmitting data in web applications. In simple word, JSON is an language independent data format. So you will have a file call or a format of the data that is key and value pair. Okay, and JSON value can only be can be this data type, that is string, numbers, objects, arrays, boolean, and null. Out of this you cannot have another type of JSON value, okay, or not the data type. This is the max kind of data type you can have. Okay, and what is the example? You can see example this two here. Now example part I will show you practically, because this is important, because you will be using a lot of this JSON. Okay, now let me show you the JSON example here. Let me just clean up the screen a bit also. Here, so to use JSON, you have to first import the JSON module. So import JSON, and for example, we have one JSON data. So one JSON string, for example, name is Sandip, age is 30, and city is Kolkata. Okay. Now this is a JSON, but JSON string. So make it more proper. It's a JSON string. If you want to convert it to the Python dictionary, okay, then we'll call it, okay, JSON string. So this JSON string we are then converting to a Python dictionary, and then we are calling the attribute. So or the key pairs, right? So key is name, value is Sandeep, key is age, value is 30, key is city, value is Kolkata, right? So mainly key and value pairs are getting utilized in JSON, and this is very common. So what happened, you work with any application, or anywhere, you have to actually as being developer, you will be working with a lot of people, or you may be working with microservices, right? Those cases you might have to fetch some data from third party, and maybe 99% chances the data is a JSON data, but it will come as a string at the first. So you have to convert the data from string into a dictionary first, in order to, if you want to process the data, you want to do some work with the data, you have to convert to a first a dictionary. Then only you'll be able to access the each key and value pairs. Okay, so for example, first I'm getting this JSON string. I'm defining a very pretty basic JSON string, then storing in this variable, then I'm parsing the particular JSON string and converting that to a dictionary. Then I'm using how to access the values of dictionary. Simply have the variable, I mean this variable, then the key name. The key name is age 30. If you want to print the name, then it will be name parameter here. So let me show you pretty quickly. Python 3, then JSON example. See, person name is 30. If you want the name, so the name, we have to use the name key, and it will do the person name is Sandip. This is a way you can use the JSON module, and you can use the JSON here. Okay, now if you want to convert a dictionary into JSON string, how will do that? That is also you can do. I think let's, okay, so look at here. So person dictionary, let's actually change all the objects to dictionary. Oh, it's only one place I'm using is, so yeah, this one. So now we already have one example where we have the value, name is Sandeep, age is 30. We converted this string to a dictionary first, then age, suppose I want to modify the value of age is 30, I want to make it 45, although I'm not 45 by the way. Now if that is the one that you're done with all the changes, now you have a string, I mean you want to convert as a string and maybe save as a value to some file and all that, could be any use case. How we can convert this object to a string so that we can store it somewhere? We have to use a function called dumps. So use the module, JSON module, then call the method dot dumps. It convert all the dictionary keys and values into string. So just like this string, this dump method will generate a string equivalent to this. The only change, age is 30, it will be changed to age 45. So let me show you quickly and you will get a very good idea of that. See, it become like this. Name is Sandeep, age is 45, city Kolkata. We just modified the value of age and we just converted to again a JSON string that we did here. Okay. and this is the function for now. I mean JSON.dumps, then the dictionary variable name. You can do that way. Okay, so this is how you can deal with the JSON data. Let's see the slide and let's move to the next. We are very near to the only few slides remaining, by the way, if you are concerned about the timing. I know we started from 11. Hopefully I think within next 30 minutes it will be over. So let's see. Then we have the Python request module. So what is this request module? Suppose you want to work with third-party APIs, then it is inevitable to call the particular API to fetch the data. And how can you do that? How can you fetch the data from those sources? You can do like this. You can use a request module. Now Python has a lot of module, right? Request, it's actually kind of external module. You have to import using say pip install request module, and using this request module we can make request to any web pages or APIs. Now what is a, I mean, if you ever used in web development, there are HTTP method you can use. Okay, and here also you can just call those HTTP method. Similar to those HTTP method will be have the functions like get function, head function, post function, put function, patch function, delete function, and request function to either fetch the data, fetch the head status or the headers, create some data using post, update some data using put, patch the data, just minor data update, delete if you don't require the data anymore, and request for specialized use cases. Okay, so this is one way you can use the request module. And you can see the example in here, which is how we are doing it. X is equal to request. I think first have to import the request, of course. So import request, then X is equals to request dot get, that you have to give the URL, and then you can print the text. Okay, now let me quickly give a demo of that. It's a very quick example I have. So request module example here. So if you see here, let me go to request module example, and then we call it Python 3, then request module demo. So okay, then you have to install. See, that's what I'm calling. If sometime if the you didn't install the request module, you'll get this error. So pip3 install, then requirements, just a moment. Yes, or maybe pip3 is not required. Pip. Oh, I have to forgot that I have to activate that one. It's okay. Let's see requirement we have request, right? So we can just also call pip3 install request. Yeah, it will also work. So it will simply install. For the using requirement, you should be using a virtual environment. We'll come to that as well. What is virtual environment? How to use virtual environment? But for now, think about if you want to just quickly install the request module, you can just use pip3. Make sure it's not, if you like me, my MacBook have Python 2 and 3. It's kind of complicated. That's why it's better to have virtual environment. I will come to that shortly. So pip3, then install the request which you already run and install it. So this will not install anymore. Now if I run the script, so for example Python 3, then this request module demo, see it printed the, it called this API HTTP bin, and it simply fetched the text whatever response it got. Okay, this is pretty basic example. You will have a assignment also on this request module, which I will tell at the end of the video. Now let's come to the video, I mean the slides again. Okay, I think yes, this is the one. This is the last slide. I was explaining about request module, right? And there we face the issue, isn't it? The issue is that I try to install requirements for some stuff, and I have Python 2. I might have different version of Python installed in my system, which makes it more complicated or while you work on different projects. What if we can avoid that? we can avoid that by using virtual environment in Python. So in Python, we can create virtual environment to manage the dependencies of a project, both in development and production or staging kind of way. And here you see that why is needed. I mean, you saw that issue anyway last time, but just to give you a more context, uh, the more Python we have, it's more likely that we need to work with different version of Python libraries. Of course, like we'll be working on a lot of Python projects, and it's not that you'll be working on same version on all the projects, right? It might break something, isn't it? So newer version of libraries of one project can break compatibility with another project. So suppose you install a new version, there are high chances that might break any module that you're using previously with that is breaking. Okay, or maybe some function got depreciated. It's quite possible, right? So on those cases, what you can do is actually use virtual environment, and these virtual environments are independent group of Python libraries, one for each project. So for each project, you can create one virtual environment, and packages installed for one project will be not affect other projects or operating system packages. So you're isolating everything. Okay. Now, how to create the Python environment? So, for example, let's go to code. And of course, you can just explain here. So, we'll just go to your project, and there we'll run Python 3-m. Then we'll be using the venv module of Python to create the virtual environment. Now, creating is not enough. You have to activate the environment. How you can activate the environment? Where you've created your this particular virtual environment, the final directory, there you have to call like dot or source, whatever you want to call it, dot or source, then space, then venv, the directory created, slash bin slash activate. So this venv directory, the venv part is, it's actually your directory. Okay, now let me show you so that it will make more sense, and we're actually pretty near end of the session within few minutes probably. So just watch this carefully. Here, if you see here, let's see. Okay, what I will do, I will use the so I can just create another folder, that's fine. So let's come here, say, and let's create a directory. Okay, go back, or maybe this particular request module actually that doesn't have a virtual environment. So what we can do, we can write Python 3-m, then venv, then venv. So what it'll do, it will create a particular directory where it will automatically create the virtual environment. Okay, so that's what we look for, isn't it? So let's do that. See, it's created a directory where you have 3 folders, but mainly we are more interested in this bin folder, and there is this activate binary is there. Okay, so we just have to activate this, and that's it. You can always go and look at what is happening. So it's deactivating all other environments, and it's just activating this environment, all the setting virtual environment path, doing all the stuff just to make sure this environment is actually isolated Python environment from other places. That's what is happening here. Now, in order to activate this Python environment, what we have to do, we have to run dot, and if the dot doesn't work, you can use this source command as well. Since the dot works in my machine, I use dot, then bin, sorry, not bin, then venv, the directory. Just clear this first, so much cluttered. So dot, then venv slash bin, then activate. That's it. You see this particular word venv, that means your Python virtual environment activated. Now you can install, if you have any request module for this, say this requirement.txt, you can install the requirement. So pip install this requirement, and I don't have to give, and for example, if even if I write execute this particular uh, function, I don't have to use Python 3 because by default it's now Python 3. So if I do Python then dot version, you see it's Python 3. I don't have to every time use the Python 3 command. The moment I activate the environment, everything is set. Now if you want to install the requirements, suppose you have the module requirements, you have put in requirement.txt. There you have to run pip install -r then the requirements.txt, and see it will install all the requirements that you have. So this is how you should be using a requirement.txt. Okay, now let's go back to the slides, and now you understand how to activate the virtual environment, right? And this if you create this way, then this projects this request model requirement is actually private and isolated to this particular request module example project's virtual environment. It will not be not conflict with any other requirements or any other projects. Okay, that is the beauty of this. Now let's go back to the slides. 11. Okay, slides. So now we understood what is virtual environment. It's just the isolated environment that we create for our different Python versions projects. It helps us to avoid the conflict. It helps us to have the requirement getting installed for the particular project only and not for the entire system, right? Those are very good benefits. Now let's come to the real life use cases. Up and running with Flask. Now just to save the time of your and mine, I have created one sample Python app, and we have dedicated Python say API development training session coming. So we will cover all those there. But in this session, just understand what is this Flask all about, and how to create such Flask in Python virtual environment, how to activate and how to run the Flask. Okay, I want to keep it very simple. That's the thing. Okay, so what is Flask? Flask is a web framework that is required for web development or web API development. Okay, and of course it's a Python module that let us develop web application easily using Python. It is a small and easy to extend code. So the thing that we download using this say Python module as a Python module, that's very small. But we can also of course add another module, not another, add different module to extend this even further, and we will cover that in our next session when we cover this API development and web development using Flask. Now it's called also a micro framework, that because that doesn't include ORM or any additional feature. This is just pure core API development library. Okay, now API or web development, by the way. Now it does have many cool features like URL routing, template engine, and WSJ web app framework. So what you see, what you get, that kind of. So mainly MVP, say model view control, MVC concept also here is available. Okay. Now how to install the Flask? You just simply have to create the first virtual environment. So first create this link. I've given all the step, by the way. So create the directory using mk flask app example, then go inside the Flask app example and run python -m vnv just like I showed you a few minutes back. Then activate the environment, then install the Flask. So just run pip install Flask and then save this dependency, because at the beginning you might not have a requirement.txt. You might just have like nothing, to be honest. So what you want to do, you want to simply install first and then freeze the requirement using pip freeze and then greater than requirement.txt. Then it will save all the dependencies into this requirement.txt, so that when you share this application with any other coworker or developers, they all have to do run pip install then -r then this requirement.txt, and it will install all the requirements that you have. Okay, and here this side you will have all the examples. I will just excuse myself from here. Say below are the example you have, like the very pretty basic example, like from Flask import Flask, then from Flask we're importing request and JSONify, then I'm just simply running a sample function, a sample Python app. Let me just quickly show how I'm running it, so it will be easy for you guys. Okay, code. Yes, let me clear the screen also. So now this repo, actually I've shared the last video. I will share this video again, full repo link with this episode links, so that you can get started very quickly. Now this is the Flask example, and this is the this index py. This is pretty basic. Okay, nothing special happening. All that I'm importing from Flask, import Flask. From Flask, we're importing request. Then we are defining the basic app. In say app is equal to Flask. Then the name is the default name of this file. Then we are defining different functions, and see decorators. We learn decorators, right? So we are writing a function then getting enhanced using this decorator. Now what this decorator is enhancing or adding feature, when you go to, I mean, after you run this application, you go to your browser and go to this particular URL of the app, then it will print welcome. So it print not in the command line, it is not just simple return, it will return to your browser. Okay, so this browser will get a HTML content which only will exist this welcome. Who doing this is happening via this decorator function. How this decorator, who providing us this decorator function? Python provided us this decorator function, because we are creating an app from Flask, and it's returning as a this function. And this function, I mean not this function, this object, and this object has a decorator function, this one app.route. This is creating a decorator function using which we are providing this normal function, and it is becoming a API. So this is how we can do. This is why, if you have clear idea of what is decorator, you could have catch it very quickly. Okay, so we are defining app, Flask app. This is an object coming from either Flask package. It could be class and all. If you want to see what is this Flask, you can just go to the Flask. I think that's not installed, so you have to. We can actually activate the environments, by the way. So bean activate. There is, I forgot to have that one, but anyway, we can check here. So Flask, it will, if it's getting installed, you will see what is the Flask have. Okay, so I mean you can go to their main repo also. So this kind of we can go to the Flask repo. It's a module, right? There you can see, is it a class, is it a package, what it is, you can find it there. Of course it's a package. From package we are importing as a module, and then module we are creating some kind of object. Okay, and their object has method, which is a decorator method, and we are just decorating all the function. Okay, so for example, hello world, it's just getting this request argument, all because, and see this request and all this coming from what, because we enhance this function, because if this function doesn't have request, this function doesn't have a request argument, nothing, not even the user and all that. Okay, because user we are getting from there only, but this request is not there. If you add this decorator function only from Flask, then only we are having this advanced functionalities. So have a better idea about this decorator also. Now this is pretty basic. If I want to run this particular app, we just have to first go to the Flask. Let's go to cd dot then cd Flask app example, then let's activate dot the space bin, sorry, vnv, then bin, then activate. See, it's activated. Now if we want to run this, let's see how we can run the application. We have these instructions, so we have to run python then index.py. So let's come here and let's go to the code and let's run python index.py. See, it's running on this particular here. So what happening, let me just quickly run it in the browser and show to you guys. So yeah, let me switch the view. See, it's printing in the browser. Welcome. And if we go to our code again, let's see any other here, hello world. So let's see that one also uh, as a URL. Hello world. See hello stranger. If I say hello stranger, and if you, let's think the condition what I put in that here, and if you give say request arguments at user, you can give user and all that as well. So just I'm not going to go for the API development or web development today, just a simple Python, right? So when we go for when we in the upcoming classes, when we learn about advanced Python web development and all, then we'll cover all these request parameters, response status codes and all things in very advanced way. Okay, for now just think this is the simple function you're calling using some modules. Okay, now you understand. If you follow from the basics to now, it all start making sense. What is a variable, what is an object, what is a classes, module, then the functions, decorators, recursive function, everything start making sense if you follow from the very beginning to now. Okay, that's why basic building blocks are necessary for advanced stuff to happen. Okay, now this is the Flask example. We have one, this one we call it, we have this git Django also. Okay, let's quickly go through. Here, get automation, get up and running with Django. You see, just like Flask is a framework, we have another very good and very widely adapted framework called Django. Now, what is Django? Django is high-level Python web framework that encourages rapid development, clean and programmatic design. Built by experienced developer, it takes care of most of the hassle of web development or API development in general. Then, so that you can focus on writing app without need to worry about reinvent the wheel, and it also free and open source. Okay, so here is also the how you will start the virtual like activation virtual environment. Same way, you first create the environment if you have not done already, then use that, go to the directory where you have this Django project, and have this dot then space vnb that's been activated, will activate it, then install python -m sorry is that pip install Django, it will do install Django. Then if you just you have this code, right? If you want to create a blank, not say blank, it's a dummy project at the beginning, you can run Django admin, this one. Okay, Django admin, then start project and think the project name, it will create the project for you. Okay, then you can start the server by running python manage.py run server. Now I'm not going to go to too much detail into this because we are going to have all the session, more detail in-depth session on this thing, right? But if you want to start, you can start by following the instruction, and you have the code files here, so it will be no problem. I think you can always check to this particular repo, which is, let me just remember what is the repo, this one. Okay, python flow cloud repo, where I will share this repo link in the video description, also in the first comment, so that you can check on. Okay, now let's come to the assignment, and we are very near or close to the session, and I will take any question that you might have. Just let me give you the assignment. First assignment will be fetch multiple data from GitHub API via request module. This is the APIs of this. I mean, this I'm just giving a reference like from where you can get the idea how to do that. Okay, then the second is that create a virtual environment, then install Flask or Django, whatever you choice you want to do. Make a very good looking web page with very good looking just have the web page, and then basically so that when the visitor come to home page, it will throw some HTML page. Okay, I don't want to be too much fancy, but just basic page. That should be the pretty basic thing if you are just getting starting with all these things. Okay, that's what I'm seeking from you guys. Now that's it for today's session, where there will be of course a lot of advanced sessions coming, but these sessions that we did today, these all are the basic building blocks. because without knowing variables, without knowing function, without knowing conditionals, without knowing the variable assignment, without knowing functions or modules or classes, without all this you cannot survive in this Python world. You find very overwhelming. If you know the basics and going through very small steady baby steps, then only you will feel more confident, more easy to do a lot of stuff, right? That's what is required. Now if you have any questions, feel free to let me know. This document, by the way, and this repo, I will share everything. Just you can use it the way you like. Let's see if anyone have any questions or not. Okay, I'll just quickly go to the LinkedIn also. In YouTube also, anyone, if any questions, feel free to let me know. I'm checking the LinkedIn for any questions. Oh yes, is Flask and Django useful for DevOps or not? Yes. See, not okay. I will give you two very solid reasons. First is that as a as a DevOps engineer, we might have to work with Django and Python just to make maybe CI/CD pipeline for the same, maybe performance optimization of the application, maybe containers of this application. We need all this knowledge, right, for Django and Python if you want to work there. Now, if you have the knowledge, it will be time saving. You may deliver a better solution for the problem at your hand if it's related to the Django and Python. And now, not just that, you want to develop your own website, maybe your own profiles website, maybe you want to create a website. Why not learn it? You are a DevOps engineer doesn't mean that you are restricted from doing web development and other stuff. You can do web development. You can for site works, maybe your own website development, maybe something that you want to build. So if you have a web development knowledge, you can build stuff, right, for you. That's a good thing. Of course, it can work. It will help you professionally as well as it will help you to build your own stuff and other things. So yeah, it's a good thing too. If you, of course, Flask and Django is not, I would say, necessary, but it's a very good thing for DevOps related use cases. And suppose you want to, you want to develop an app which fetch some, external stuff, which do some automations for your DevOps use cases. You can do that also. It's all based on the use cases. Yes. John from Lucknow. Okay. Currently in office. So Vishek Verma saying John from Lucknow currently in office. Oh my God. Sunday also you guys are officing. Will this be used for DevOps as well? And this is why I covered Python in DevOps, because see all these things, this API development, this debugging, importantly, if you don't know how to program, how can you debug? You can by googling, but it's take a lot of time. If you have the knowledge and experience in something, it takes less time later on. So that's why it's required, I would say. Okay, looks like not much questions today. Then I will just end the session here. By the way, thanks everyone for staying this long. I know it's long session, not a small one, but thank you for staying all this long. Okay, I will not immediately, but after a few hour, I will share this video, this document, that PDF slides, and I will share the Zippo. Okay, so have a nice day ahead, and if any question, feel free to let me know in messaging or this comment in this video. I'll definitely reply back. Okay, bye everyone. Thank you for watching, and if you are new to this channel, do subscribe the channel. It will be awesome to have you here. Thank you.